Good morning to everyone. I'm Abhishek Shukla from Wiltech final year student. I'm doing my project in Delphi TVS. That company actually makes auto parts. My internal guide in that company is Mr. G. Sanmoga Sundaram. He is a senior engineer from that Delphi TVS, and our internal guide is Mr. S. Javelu in Wiltech. He is our mechanical HOD, and he is working on assistant professor in Veltech. So now I'll tell you about my project. My project title is Performance Improvement in Fuel Injection Pump through various reduction in BS and QS. Our team member is Anupam Pandey and Kanhaiya Bharadwaj, who also belongs from mechanical final year student. Our abstract is actually every day there is a line stoppage and low machining yield less than 70% in quill shaft and bearing support shaft. So we have to increase that percentage so that we can fulfill the customer demand. Due to this low plant, we cannot able to meet the customer demand on time. So we have to give some method to increase that productivity so that customer demand can fulfill and company productivity could be more. Our content will give the general description about quill shaft and bearing support shaft, and we will also tell you about matching process and what is the factor affecting during matching process so that company are going to decrease its productivity, and process flow of quill shaft and bearing support shaft, and we'll give the analysis. So our objective is to improve the performance of fuel injection pump so that the customer demand could be filled, and to improve the matching yield of quill shaft with the bearing support shaft. This is the assembly of fuel injection pump. What is the fuel injection pump? Simply we can say that it generates the pressure through the fuel injection. The pressure comes from the fuel injection. That pump is the pump work is created the pressure in fuel injection pump. That is the call the function of fuel injection pump, and it is uses in the in our company. And product introduction. This is the quill shaft. The quill shaft, the main use of quill shaft is it is the transmit the power from the engine through pump. Sorry, it is the quill shaft used to transmit the power from engine to pump through the drive shaft. That is the use of that quill shaft. When we will apply the load during the rotation of the pump, definitely quill shaft will break and save the other component. This is the also basic benefit of that quill shaft. And this is the bearing support shaft. Bearing support shaft also have same use. Actually, this is the dry shaft is fitted with housing using to bearing called primary and secondary, and dry shaft is assembled with the weight case and bearing, and this fixed without the through hub seal. It is also the same use to transmit the power from engine through pump, but from the driven shaft. In this is the matching component which is used inside the fuel injection pump. Actually, this is the whole matching process is the rotatory type of process in the fuel injection pump. The whole process give the it is also created the performance of fuel injection pump. The component of that matching process to increase the pressure by his rotation, and this actually matching process also I give a in our machining process the quill shaft and bearing support shaft are going to be met with each other to meet their tolerance range. This is the main cause of that matching process going to low. First is the radial play. This is the factor. What is the radial play means? It is the maximum displacement between two spline or two gears. This is the direction perpendicular to the axis of rotation. The dimensions should be inside between the 0.7 to 1.40 mm, the radial play dimension. And next one is the axial play. it is the also maximum relative displacement of gear, but the direction parallel to the axis of rotation. The difference between the axial and radial is in the radial only direction perpendicular to the axis of rotation. This also tells the distance between the splines, and in axial play also the maximum relative displacement of gear inside the direction parallel to the axis of rotation. The maximum allowance 0.20 mm in axial play uh, should not be more than that axial play. We can see that that is the moving part in axial play, that shows the maximum allowance should be under 0.2 mm. We can see that that is the rotating part. And now, what is the problem faced during matching process? When we are going to match the quill shaft and bearing support shaft, we get more scrap on quill shaft component. It means it is not rotatory part, it is not a fulfilled rotatory part on scrap. Means if we have to increase the productivity, we have to increase the matching process, we just the scrap should not be on that quill shaft. The reduction of productivity also is the main problem in that company, in that automotive parts, in that section. The matching yield percentage, we also know, couldn't meet of customer demand, so we have to increase the demand so that company gain some benefit. First time pass report. The method, what we are method going to analyze, quill shaft machining stage gauge repeatability. This is the method which we are going to do. Quill shaft machining process, quill shaft spline profile dimension, quill shaft heat treatment process. This is the quill shaft process, cutting, turning, first setup. As you can see, spline, tooth, cutting, heat treatment, these are the perfect gear. This is the gauge repeatability, which can show the axial play, which can show the radial play, and in that we can see that the maximum allowance, what we should go for it, and that allowance should not be maximum 7 point, oh sorry, maximum 0.70. This is the and our step 2 will be the machining process validation and quill shaft dimension study. You can see that our spline pin over dimension should be 20.09 plus minus 50 micron. To have a detailed study on the dimension, we have taken 50 sample of quill shaft after machining process and checked the above mentioned dimension for verification. This is the dimension. This is the diagram which we have made from the CATIA software. In that quill shaft, we can see that how much axial play, how much radial play. Means axial play should not be in axial play, the maximum allowance should not be more than 0.70 a. In quill shaft, the dimensions occur in 0.7 to 1.40 mm. This is the separately part of whole matching process. Means we have made here you can see quill shaft separate, and bearing support shaft separate, and that driven shaft is separately. By the quill shaft dimension study after machining process, we have taken first 50 sample, and after that we can see, after just we have to conclude after 50 sample what we are going to take. Spline profile satisfactory, heat treatment process. Step 4 our will be heat treatment process. So quill shaft heat treatment process is nothing, case hardening and component. Yeah, heat treatment process, we are going to see that quenching process, hardening process, like that. In carburizing, diffusion, hardening and tampering. Actually, in that process, our temperature is fixed 900 degree for hardening, 900 degree for diffusion, 825 degree for hardening, like that. Spline profile and lead in the flank. This is the rough diagram of heat treatment was what we are going to take. And observation phase, This is the observation phase first. What we are going to improve in that phase, we have written machining process, heat treatment process. Our question arises after improvement, why radial projection in machining process? And second is the why we are unable to match with bearing support shaft. And third is profile and lack of flank out of limit as per standard. Why we are going to use single point cutting tool process. So these are our question. Our solution will be change the gear cutting, means we have to replace the single point cutting tool with the gear. Change the gear cutting process means we have to replace the single point cutting tool with the gear hob. That is our solution. And quill shaft, new process development in machining. So we are going to tell you, as you can see, what is the hobbing. Hobbing is nothing but for making a gear, for making a spline. And this is the type of a milling machine, special type of milling machine. So our conclusion is hobbing method was selected for machining process instead of single point cutting tool. So after improving the machining process, we can see that what type of milling machine, what type of special milling machine we are going to use. That will be the gear hob use instead of single point cutting tool. Question is why we are going to use the gear hob. What is the benefit if we are going to use that gear hob? In single point cutting tool, we are not able to get a perfect dimension of spline. Means if before we are going, before in that company they are using that single point cutting tool, so because of that the spline variation so much, means that single point cutting tool is not able to make a same spline. Because of that we are going to change that gear hobbing, and gear hobbing is the able to do same spline in one time. So the time is also reduces, and we are also able to make that same spline, same gear tooth, and not variation. So now we are going to just see in heat treatment process why we are going to analyze this. Our question is first, why quill shaft is not matching with dry shaft? That is the main question. And second is spline profile dimension variation. That is the question. Third, as you can see, fourth, cold ion quenching, why they are going to use cold ion quenching in heat treatment process. So our conclusion will be, our solution will be, we have to change the quenching process in heat treatment so that we could meet our customer demand perfectly. And our new process in heat treatment, beforely actually quenching into oil 100 degrees Celsius had traditionally. So our main motto means temperature in the oil should not be more than 190 degrees Celsius. The temperature should be in the 105 degrees Celsius to 190 degrees Celsius. If temperature will go more, then definitely shrinkage in the material will be go more, and the perfect variation also occurs. If variation occurs, we are not able to match perfectly. So the temperature of the that material just should not be more than the 190 degrees Celsius. That's why we are using the standard hot oil quenching process selected to control the temperature, because the shrinkage could not be occur. So our improvement in heat treatment process, quenching process, just we have to use standard hot oil quenching instead of cold oil quenching. As you can see, our temperature is not more than 190 degrees Celsius. So we are not getting any type of variation, we are not getting any type of shrinkage. Before they are going to use one container of 1800 numbers in one batch. So we are going to change in 3 container, per container 600 numbers, so that the temperature will be in control and it will not be go more 190 degrees Celsius. So definitely we cannot get any shrinkage, so no dimension variation. As we can see, this is the profile and lid after oil quenching. After improvement, what we are going to take after improvement. Now the profile and lead dimension are good. with the trial component. I have taken 50 components from the trial component from matching and radial play checking. So I have revised the specification from 1.2 mm to 1.4 mm is upper specific limit. This is the performance what we have improved. So monthly plan versus actual. Our monthly plan will be 30,000 after the improvement, and before the actual is now 29,800. So near about 1200 we are going to achieve after improvement. So this is the required production rate achieved. So our target and achieved, I have achieved 96 percentage of FTPR. FTPR is first time pass report. So definitely if they are getting current 60 percentage, if we are going to make 96%, it is a huge beginning for us. Benefit of our project, what will be benefit of our project after improvement? So definitely QS and BSS matching will be improved up to 96 percentage. Definitely if we will not get any type of shrinkage, if we will not get any type of variation, so we can definitely matching process will be improved, and our production our customer demand will be satisfied. Benefit, scrap cost 30,000 rupees per month saved, and near about manpower cost also 20,000 24,000 rupees saved per month, and oversized component quill shaft rework cost, rework no need to after improvement. So definitely rework cost also we are going to save 3,10,000 rupees per annum saved. So this was our project. Means if we will go for that, in that company, three things which can do. First, we can improve the performance of fuel injection pump. Second, we can improve the matching product, so and we can reduce the time. And third is the customer demand will be satisfactory and the productivity will be increased. So we are going to just improve two type of solution. First type of solution is we have to change that machining tool. First they were using the single point cutting tool, and we are going to change in that gear hobbing. And next we have to change in heat treatment process. They are using in 1800 numbers. We have to just separate in three parts of number 600 600, so that definitely shrinkage will not be allowed, so we can improve our productivity as we can see. So I am Abhishek Shukla from mechanical fourth year. Thank you very much. Thank you.